Graph engineering costs 300 times more tokens on global searches, yet the entire industry is pivoting to it. Why? That's graph engineering. It uses structured maps to orchestrate AI agents. Here's why the industry is obsessed, why the benchmarks are confusing, and how you pick the right strategy without burning your budget. If you're building agents, using the wrong graph strategy means you'll either burn your budget on noise or build a system that collapses under complexity. You probably think graph engineering is a single unified upgrade. It's not. The term exploded in July 2026 after a 6-word post by Peter Steinberger. But the industry immediately fractured into two camps, solving completely different problems. Think of your AI system as a city. Prompts are the worker's instructions. Loops are the worker's daily routine. Graph engineering is the city's zoning map and road network. It defines how specialized departments connect, share data, and handle traffic. We'll cover 4 things. First, where this term actually came from because it's barely 3 weeks old. Second, the 2 definitions everyone is arguing about. Third, the benchmark data that proves one is overhyped. Fourth, the hidden costs, how to choose, and what this changes about building AI. First, where it came from. And the timeline is shorter than you think. Prompt engineering arrived in 2023. It was about the wording of a single query. Loop engineering entered the vocabulary in late 2025 and dominated developer talk through June. That's the observe, act, retry cycle for one agent. Graph engineering followed about 6 weeks later. On July 11th, Notice Labs posted about building a reasoning graph for your model. Then, days later, Peter Steinberger posted 6 words. Are we still talking loops, or did we shift to graphs yet? That post hit 2.9 million views. 4 days later, Xplaination.a, I published a full synthesis. By August 1st, there were comparison videos. By August 2nd, working implementations on Reddit. 3 weeks from a throwaway post to an architectural movement. And here's why the term is so slippery. The word graph is doing triple duty. A knowledge graph is a data structure describing what's true. LangGraph is a library for wiring execution flows. Graph engineering is the design discipline deciding what that shape should be. 3 unrelated things sharing one noun. Most arguments about whether graph engineering is real are just 2 people discussing 2 of the 3. Second, the 2 definitions. But before we pick a side, you need to know they're solving different problems. Camp A treats graphs as orchestration. Nodes are agents. Edges are transitions. This enables concurrency where loops fail. A loop runs, plan, code, review, and fix sequentially, one after another. A graph can dispatch 3 reviewers simultaneously. It cuts wait time to 0. Camp B treats graphs as memory. Nodes are entities. Edges are typed relationships like supersedes or depends on. This solves multi-hop questions that vector search misses. Take a real one. Why did we stop using Redis for the job queue? The answer is not written down anywhere. You have to assemble it. Redis had a June outage. RFC 1.4 superseded it with SQS. The answer is the path, not the node. Vector search returns documents that look like the question. It finds the Redis config page. It finds Slack threads with the word queue. None of them contain the answer. The graph walks 5 typed edges and reconstructs the causal chain. Now, the benchmarks. And the data reveals a surprising trade-off. Graph retrieval wins on complexity. It scores 53.4% on multi-hop reasoning. That's 10 points over vector. It hits 58.1% on temporal reasoning. That's nearly 3 times better than vector. And it reaches 64.4% on corpus synthesis. But on simple fact lookup, graph retrieval loses. It scores 60.1% versus vector's 60.9%. And it costs more. It uses 1,008 tokens per query compared to vector's 880. You're paying for a map when you just need the address. The hidden costs. But the costs hide a trap that breaks production. Microsoft Graph RAG indexing runs $33,000 per dataset. That's not a typo. $33,000. For a single dataset, global searches consume 331,000 tokens versus 880 for vector. The expensive part is deciding what is the same thing. If your system thinks Apple the fruit and Apple the company are the same, your graph breaks. It links recipes to stock prices. That's not just a bug. That's a hallucination engine. You spend thousands cleaning data just to align entities. But the costs aren't the only trap. Accuracy degrades as you go deeper. The reliability trap? Entity resolution is only 85% accurate per hop. A 5-hop chain is only 44% trustworthy. You're building on a foundation that degrades with depth. And vendor benchmarks lie. LighterAge posted massive wins on its own benchmark. Then it collapsed to an average F1 of 6.6 under independent evaluation. You must treat vendor claims with suspicion. The algorithms are only as good as the data matching. So how do you choose? Use Camp A's orchestration for complex parallel workflows where loops collapse. Use Camp B's memory for multi-hot questions where vector search fails. Avoid both for simple lookups where vector search still wins and costs less. A quick way to tell which one you need. If your agent produces the wrong answer because it never learned something, you have a memory problem. You belong in Camp B. Imagine a legal assistant missing a clause because the contract changed last week. A vector search finds similar contracts. A graph finds the specific update and links it to the current draft. If your agent produces the right answer but too slowly, or collapses when one step fails, you have an orchestration problem. You belong in Camp A. Imagine a customer support agent that fails because the payment step timed out. The graph can retry that node in parallel while the rest proceed. A loop would have crashed the whole thread. Teams routinely buy the wrong one. They adopt the knowledge graph to fix a retry logic bug. Then conclude, graphs don't work. The most useful discipline right now is simply to clarify which definition you mean. Don't assume your audience shares your camp. Explicitly state whether you're discussing graph-based orchestration or graph-based memory. So what does this actually change? Because the shift is bigger than a new tool. For 3 years, the main lever on quality was the prompt. You coaxed a better answer out of one model by choosing better words. That lever is flattening. The new lever is structure. How work is split, where it runs in parallel, what gets verified, and where a human signs off. The job title drifts from prompt engineer to something closer to systems architect. Watch 3 things. First, evaluation has to change. You can't score a graph by grading its final answer. You need per-node observability, because a system can be right for the wrong reason and you'd never know. Second, the memory layer gets standardized. Tools like Infranotice already expose knowledge graphs to models over MCP, which means your agent's memory becomes a component you plug in, not something you rebuild. Third, and this is the honest part, a lot of this will not survive. The term is 3 weeks old. Loop engineering was going to be the answer 6 weeks ago. What survives isn't the vocabulary. It's the underlying move, from tuning one model's words to designing how many pieces cooperate. That direction is real, whatever we end up calling it. So let's bring it together. Graph engineering splits into 2 definitions, orchestration and memory. Benchmarks show it wins on complexity but loses on simplicity. The hidden costs and accuracy decay mean you choose by matching the strategy to the problem, and the real shift is from prompt tuning to structure. Graph engineering isn't a magic fix, it's a structural shift. Match the graph strategy to the problem type, or you'll pay for complexity you don't need. If you want this stuff explained without the hype, subscribe. That's what we do here, daily. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.